Hey everyone, it's Bradley Bush again with another logarithm video. This is in my Algebra playlist, and if you would like to look at other videos, I've got a ton of them there for you. Today, our to-do list, we've got 4 things. First thing, give you a brief intro to logs. I do a more in-depth introduction to logs in another video that you can check out. But just to give you a little base before I go on to properties, which is the main focus of this video, I'll give you a little bit of intro. Then we discuss log properties. And after that, a brief discussion about natural logs versus common logs. And then perhaps something super useful for you is how to use natural logs and common logs on your calculators. So let's go. Let's start with the definition. Let's discuss what is a log and what do I need to know about it to just be able to be functionally useful here. So this right here is the big cheese. This is what we care about. This is what a logarithmic function looks like. You have an input here, which is your x. So that's also this x value here in the definition. And notice it's restricted to be strictly positive. So x has to be bigger than 0. We have a base for our logarithm. That's the wrong color. We have a base for our logarithm. Let's do orange for our base. Here b is the value that represents the base. But the base in an actual logarithmic function will be a number like 2 or 5 or something like that. Here is just represented as a letter b. And this also has a restriction on it. It has to be larger than 0, but it cannot be equal to 1. So it can be between 0 and 1, and it can be greater than 1, and that's it. And then, finally, we have an output of the logarithmic function. And the cool thing about the output is the output of a logarithmic function actually is an exponent. So logarithms are just really exponents. The output, the result of a logarithmic function is just an exponent. So we have 2 forms here. We have logarithmic form, which I just discussed with you, and we have an equivalent exponential form for every logarithmic form. So I color-coded it here. So you can see the b, the base, is blue for each of these, the logarithmic and the exponential form, and they're identical. These 2 b's represent the same numbers. So I've got a video where you can switch, that teaches you how to convert back and forth between logarithmic and exponential form. I use the exact same numbers here, the 2 b's. We also have these y's, the purple y's. Those are identical. They represent the same thing. They're the same color. And their inputs on the logarithmic side, the x's, become the outputs on the exponential. So the input on the logarithmic, which is the x, becomes the output on the exponential. And the output on the logarithmic, which is the y, becomes the input or the exponent on the exponential. So on the left we have the logarithmic function with base b, and on the right we have the exponential, the equivalent exponential function with base b. There is your couple-minute introduction to logarithms. Hope that was helpful. All right. Here's a note before I keep going. If you struggle with the following examples, because I'm going to evaluate logs without using a calculator, I'm just going to talk about them, and you might, if you struggle with it and you think, where in the world is he getting these? I don't understand how he's computing these. Then please watch my video in my Algebra playlist called Convert Between logarithm and exponential forms and evaluate logs without using the calculator. This part right here is what I'm referring to. It's at the end of that movie. I'm not a movie star. It's at the end of that video, and it might be helpful. All right, let's talk about basic logarithmic properties. So here are 4 basic properties that are actually super, super helpful. I have a little bit of explanation in green and in purple, and then I have an example on the far right of each of these properties. So the first one, log base b of b is equal to 1. So log base b of b is equal to 1. We know this is true because when we evaluate a log, really what it's asking is, what do I have to raise this base to get the input? So because b to the first power is b, the result is just 1. So this seems kind of obvious to us. So our example on the far right would be log base 5 of 5. Well, it's really asking you 5 to the what power is 5? And, well, you're thinking, yeah, it's 1. 5 to the first power is 5, and I just erased something I didn't want to. 5 to the first power is 5. So the answer here is just 1. Second rule, log base b of 1 equals 0. Well, that is because b to the 0 is 1. Anything to the 0 power is just 1. And that's really what we're doing. That's what this function, this rule is telling you. It's asking you a question. It's asking, what do I have to raise b to get 1 back? What power must I raise b to get 1 back? And it's 0. So over on the far right, our example, log base 5 of 1 is what? Well, 5 to the what power is 1? 5 to the what power is 1? 5 to the 0 is 1. Anything to the 0 power is 1. So our answer here would be 0. Because 5 to the 0 power is 1. Next property, property 3. Log base b of b to the x is equal to x. This is the first of 2 inverse properties. Inverse properties, I don't know if you remember back in algebra, but there's a definition of inverse functions. And the definition of inverse function says if you have 2 functions, f and g, and you take their composition, meaning you take f of g, you plug g into f, or plug f into g as an input. If you get back just x, that means those 2 functions, f and g, are inverse functions. So this property discusses that fact, that mathematical fact. Logarithmic functions and exponential functions are inverse functions if they have the same base. So these 2 both have the same base. Notice this is base b for the log, and this exponential is base b. So we're just going to get back x. It's as if these 2 things right here, because they're the same, they kind of cancel. That's a layman's version of what goes on. So mathematically, we know that the inverse property gives us x back because these 2 functions are inverse functions. So our example to the right would be log base 2 of quantity 2 to the 6th. Well, these 2 functions are inverse functions. They both have the same base, 2 to the 6th and log base 2. So what we get back is just this thing right here, which is 6. Last property of the 4 is another inverse property, but instead of starting with a log like we did in the previous example, we're starting with an exponential, and our log is in the exponent. So b raised to the log base b of x, the exponential with base b and the log base b cancel when they are composed, meaning we take one and put one as the input into the other, and what we get back is just x. So over in our example on the far right, let's check this out. 5 raised to the log base 5 of 12. The 5 in the base of the exponential and the log base 5 cancel, and what are we left with? Just that. 12. Sweet. Those are actually super, super useful properties. They're good to have in your back pocket on a piece of paper somewhere when you're doing these types of problems, because you pull it out and you reference it, and they really can help you when you're stuck. All right, we've finished discussing some basic properties. Let's talk about natural logs versus common logs. There's some types of logs that occur so frequently that they've given them their own symbol. So normally when we write out a log, we will have log base b of x and y. This is all equal to an output y. So they normally have this little base, so that you know which base you're referring to when you write a log, because every log has a base. So there are two types of bases that we don't need to write because they have their own symbol, their own way of writing it. So the first one is natural logs. Natural logs right here, they're logs with base e. So they would be log base e of x. We don't write it log base e of x. We just simply write it ln. L as in log, n as in natural. So if that helps you remember, great. So ln of x, just remember that's really just log base e of x. The second type of super common log, I didn't want to use that word, but I couldn't think of another one, is actually called the common log. The common log is base 10. So instead of having a base 10 there, they just don't write anything. They just say log of x. If you see log of x, L-O-G, excuse me, then you can assume that it's the common log and it's base 10. Both of these, ln of x, so natural log, and the common log, log base 10, those are the two most frequently used logs, and they both have calculator buttons that you can use, and we'll discuss that in a couple minutes. I'll show you how to find those on your calculator. But these are the two most frequently seen logs, the natural logs and the common logs. So all of the properties that we just discussed, those 4 properties above right here, all of these properties have common log and natural log versions. The principles inside them are the same. They are just written, instead of log base b, generic log base b, they're written as natural log and common log. So here are examples of those. I'll quickly run through them because, again, they are the same ideas as the 4 that we went above. But it never hurt to go over something more than once. So with the natural logs, we'll start first with rule number 1. ln of 1 equals 0. So that's because e to the 0 gives you back 1. ln of e, the second one, the natural log of e gives you back 1. And that's because e to the 1 equals e. Third one, the natural log of e to the x is just x. Again, these are the two reciprocal properties. So we saw that ln of x, that's really just log base e. So that base e and the e in the exponential cancel. And what are we left with? This thing right here. X plus 3. Fourth example, e to the ln of x is just x. And an example of that would be e to the ln of 6. And again, the e and the ln cancel because ln is log base e. Since they have the same base, it's the reciprocal function. And they cancel out, and we're left with just what's right there. So 6. So again, if you look up at the discussion above, these are the exact same principles. They're just written in natural log, with natural logs instead of log base b. So over to the right, we can go over the first property, log of the common log. So log base 10 of 1 is just 0. That is because 10 to the 0 power gives you 1. Second one, log base 10 of 10 is just 1. That's because 10 to the 1 equals 1. And if you're thinking about that for a second going, I don't get it, go back above to the discussion on the original 4 properties and look at them closely and then come back here. And remember, log base 10, you don't see the base. The base would normally be down here, right, and down here, but we don't see them because it's the common log, so it's assumed to be a 10. Third property, log base 10 of 10x is just x. Because, well, let's just do an example. Log base 10 of 10 to the 7, so this really is like that. And remember, log base 10, we've got a 10 there that is not being written. So this log base 10 and the 10 cancel, and we just get 7. Last one is the exponential version of the inverse property. So 10 to the log base 10 of x just gives you back x. So we can see this here. The logs cancel because this, again, is base 10. And what we're left with is this, x minus 2. Perfect. All right. Finished with our objective number 3 in our to-do list. And this is number 4, which is to talk about the calculator buttons. We got 2 of them. We have ln of x and we have log x. You'll see both of these on your calculator. This is what your calculator should look like. Any of the family, TI family, should look like this as well. This is a TI 84, but your TI 82, 83 should look very similar. The 2 buttons we have are log, which is log base 10, which is the common log. That's right here in the left in red. So we said log base 10 of 10 was 1, and there we see it's 1. We see it in our calculator. The second button we have on our calculator, it's a log button, is this button right here, the natural log, ln. Some students think that this is in, it's ln. We said log, natural log of e, let's do e to the 1 What did we say that was? We said it was 1, and there we see it's 1. So the two buttons we have that we use frequently are the log button and the natural log button. That's it. Hope you enjoyed the video. Have a great day mathing.